morning everyone. Today we see next unit of advanced discrete mathematics subject, that is solving recurrences. In that solving recurrences unit, we see the different methods to solve recurrence relation equations. So the first method is linear homogeneous recurrence relation. Second method is linear non-homogeneous recurrence relation equation. Third method is method of inspection. Fourth is method of telescoping sums. And fifth method is method of iteration. And last one is method of substitution. These all methods we see in today's session. So firstly we see how to solve linear homogeneous recurrence relation equation. That is how to find out the solution of linear homogeneous recurrence relation equation. So firstly, linear homogeneous recurrence relation equation is in the form un plus a1 un minus 1 plus a2 un minus 2 plus up to ak un minus k is equal to g of n. In that given recurrence relation equation, un minus 1, un minus 2 up to un minus k are the variables and a1, a2 up to ak are the constant values, and the last one g of n is a function of n. How to check the given recurrence relation equation is a homogeneous or non-homogeneous? If the function value, that is g of n value, is equal to 0, then given equation is a homogeneous equation, and if the g of n, that is a function of n, value is not equal to 0, means any number 1, 2, 3, then this equation is called non-homogeneous recurrence relation equation. So firstly we see how to solve or how to find out the solution of linear homogeneous type of recurrence relation equation. If the linear homogeneous recurrence relation equation is in the form un plus a1 un minus 1 plus a2 un minus 2 up to plus ak un minus k is equal to 0, means g of n value is equal to 0, then this equation is called linear homogeneous recurrence relation equation of order k and degree 1. To solve the linear homogeneous recurrence relation equation, firstly we put value of u as z and value of n as k. Firstly we write n as order, but in next format we write n as power. For example, un plus a1 un minus 1 plus a2 un minus 2 up to ak un minus k, we can write this equation in the as the z format, that is put u is equal to z value and n is equal to k value. So we can write un as z raised to power k, n write as at the power of k, at the power of z, means plus then second term a1 into un minus 1, we can write this term as a1 as it is write down, then un minus 1 at the place of u we can write z, and n minus 1 we can write z raised to power k minus 1. Similarly, next term a2 un minus 2 we can write as plus a2 z raised to power k minus 2 up to so on. Last term ak un minus k write as ak into z raised to power k minus k. If we put n value as k, then z raised to power value we get k minus k is equal to 0 as it is. Then when we find out the root of this equation, that is homogeneous recurrence relation equation, then we get z minus alpha 1, z minus alpha 2 into z minus alpha 3 up to z minus alpha k is equal to 0. Therefore, the roots of this linear homogeneous recurrence relation equation are z is equal to alpha 1 root, alpha 2 root up to alpha k roots. These all are roots of the linear homogeneous recurrence relation equation. Then if these all roots, that is alpha 1, alpha 2, alpha 3, all roots values are distinct, means different values. Alpha 1 value is, for example, 1, alpha 2 value is equal to 2, means all values of roots are different, that is distinct. Then we use this formula to find out the general solution of the given recurrence relation equation. That is un is equal to a1 into alpha 1, that is first root raised to power n, plus a2 into alpha 2, that is second root raised to power n plus up to so on ak into alpha k, that is last root raised to power n. But if the value of z are repeated, means all roots, in the all roots first two roots values are same, that is alpha 1 is equal to alpha 2, then we get the general solution formula is un is equal to a1 into n plus a2 multiply by alpha 1 raised to power n plus a3 into alpha 3 raised to power n plus a4 into alpha 4 raised to power n. Next condition, if the value of first three roots are equal, that is alpha 1 is equal to alpha 2 is equal to alpha 3, means alpha 1 is equal to, for example, alpha 1 is equal to value is 1, then alpha 2 is also 1 and alpha 3 is also 1, then the first three roots value are the same, then we find out the general solution of this type of recurrence relation equation using this formula, that is un is equal to a1 n square plus a2 into n plus a3 into alpha 1 raised to power n plus a4 into alpha 4 raised to power n, and so on, where in that equation a1, a2, a3 and a4 up to ak, all these values are constant values, means any term, that is 1, 2, 3, 4, any numbers. So let us see how to solve the linear homogeneous recurrence relation equation and how to find out the solution of linear homogeneous recurrence relation equation. So the question is an is equal to 4 into an minus 2, where initial conditions values are given a0 is equal to 4 and a1 is equal to 6. Firstly, we see the given linear recurrence relation equation is a homogeneous or not. If we see that this given equation an is equal to 4a n minus 2, then we can write this equation as an minus 4a n minus 2 is equal to 0, means function value is equal to 0, means this given equation is a linear homogeneous recurrence relation equation of order is equal to 2. Then firstly we can write this equation in the format of z, that is we can write an as z raised to power 2 because order of this equation is 2. Then z square is equal to 4 as it is, write down a n minus 2, write as z raised to power, put n value as 2, that is 2 minus 2. Then z square as it is equal to 4 as it is, z raised to power 2 minus 2 answer is 0, that is z raised to power 0 answer is 1, therefore 1 into 4 answer is 4, that is z square is equal to 4, we get the answer. Then we find out the roots of z, that is values of z is equal to plus 2 and minus 2. Then we find out the general solution of this given linear homogeneous recurrence relation equation using first formula. If the roots are different, that is distinct, then an is equal to a into first root, that is alpha 1 raised to power n, plus b into second root raised to power n, that is alpha 2 raised to power n. Then we have the initial condition a0 is equal to 4 and a1 is equal to 6. So initial given conditions are a0 is equal to 4 and a1 is equal to 6. Therefore, we put value of n at 0. Then we get a0 is equal to a as it is, 2 raised to power n, value put n is equal to 0. Then 2 raised to power 0 we get, plus b as it is, write down, minus 2 raised to power n value put at 0. That is b into minus 2 raised to power 0. Then we get the solution a0 as it is equal to as it is a into 2 raised to power 0 answer is 1, that is a into 1 answer is a, plus as it is b into minus 2 raised to power 0 answer is 1, that is b into b multiplied by 1 answer is only b, that is we get a0 is equal to a plus b. Then we put value of a0, that is 4, in that given equation, that is next equation is we get 4 is equal to a plus b. So this equation is the first equation, we mark as this first equation. Then next step to solve the recurrence relation equation is put n is equal to 1 value to find out the next equation same as it is. Similarly, if we put the value of n is equal to 1, then we get the equation as a1 is equal to a into 2 raised to power 1 plus b into minus 2 raised to power 1. Then a1 value we given as a1 is equal to 6. Therefore, we put a1 value as 6. 6 is equal to a into 2 raised to power 1, answer is 2, that is 2a answer, plus as it is. Then b into minus 2 raised to power 1, answer is minus 2, that is answer is plus minus 2 into b, that is minus 2 multiplied by b. Then 6 as it is write down is equal to as it is, 2a as it is, plus minus answer is minus, and 2b as it is. Then from this second equation we get, if this whole equation is divided by 2, we get the next equation as 3 is equal to a minus b. Then this second equation and the first equation we solve, that is a minus b is equal to 3, this second equation, and we write down the first equation, a plus b is equal to 4. When we solve these two equations, minus b and plus b cancel, a plus a, answer is 2a, is equal to 3 plus 4, answer is 7. Therefore, we get the value of a is equal to 7 divided by 2. Similarly, we have to find out the value of b, that is using equation first, a plus b is equal to 4. We put the value of a at 7 divided by 2. Then after putting the value of a 7 divided by 2 plus b is equal to 4, then we get value of b is equal to 4 minus 7 upon 2. That is 4 into 2, 8 minus 7 divided by 2. That is b value is 1 upon 2. So we find out the a and b values. Then we put the values in our general solution equation. Our general solution equation is an is equal to a into first factor, that is 2 raised to power n, plus b into second factor raised to power n, that is minus 2 raised to power n. Then we put the value of a and b in this given general solution equation. Then we get last solution of this equation is an is equal to 7 upon 2 into 2 raised to power n plus 1 upon 2 into minus 2 raised to power n. Next question is an plus 1 square is equal to 5 into an square, with initial conditions given are a0 is equal to 2 and find the value of a8. Then firstly we let bn is equal to an square. Then we put the n value as 0 because of the initial condition a0 is given. So b0 is equal to, when we put the n value as 0, b0 is equal to a0 square. Then b0 is equal to, a0 value is given, that is 2, we put 2 square. Then b0 is equal to square, answer is 4. Therefore we get b0 is equal to value 4. Then similarly we know that our question is n plus 1 square is equal to 5 into an square. We write down this question. Then we know bn, we let bn value as an square. So at the place of n we can write as bn. So next equation is bn. At the place of n square we can write as bn plus 1 as it is equal to 5 as it is. At the place of n we can write as n square, we can write as bn. Then this next format of equation is bn plus 1 is equal to 5 into bn. So this equation we convert in the homogeneous form. Bn plus 1 minus 5 into bn is equal to 0, means function value is 0. Therefore this is a linear homogeneous type of recurrence relation equation of order only 1. Then we find out the root value, that is z is equal to, directly if the order of recurrence relation equation is 1, then this value is a root of given recurrence relation equation. Therefore root of this linear homogeneous type equation is z is equal to, directly answer is 5. Therefore root is given 5. Then general solution of this type of equation, bn is equal to a into alpha 1 raised to power n. So alpha 1 value is 5. We put this value 5 raised to power n. Therefore general solution of this equation, bn is equal to a into 5 raised to power n. Then we have given value a0 is equal to 2 and we find out the value of b0 is equal to 4. Just n is equal to 0, we put the value bn is equal to a into 5 raised to power n. Then just put value n at 0. Then b0 is equal to, next we get a into 5 raised to power n value at 0 put. Then b0 value is equal to 4, we put in that b0 place, is equal to a into 5 raised to power 0, answer is 1. That is 1 multiplied by a, answer is a. That is a value we get, a is equal to 4. Similarly bn is equal to 4 into 5 raised to power n, we can write this equation. and